Section 4, we're going to be taking a look at applications problems that involve the sort of equations that we've been learning to solve. Let me go through the 4 steps for solving word problems, applications problems. And these are just general guidelines. They're not set in stone, but this will help if you'll follow along. Step 1, identify the variables. That means decide what you're looking for and what you're going to call them. Step 2, come up with an equation. This is usually the hard one. Step 3, solve the equation. Step 3 is the one of these that we've been dealing with. And then interpret the answers. Let me show you how the 4 steps work with this word problem. Step 1, identify the variables. Read through the problem. When you get to the end, you'll usually find what you're looking for. We want the length and the width of the rectangle. So we'll write that down and come up with something to call that. We'll call one of them x, but the other one has to be something besides x. If it was the same, then it wouldn't be a rectangle, it'd be a square. And so the other one from this sentence needs to be 3 less than 2 times the first one. And so there's our 2 variables that we will use throughout the rest of the problem. Step 2, write the equation. If you get in the habit of kind of marking your problems like I have here, the stuff that I have highlighted we've already used, so don't go looking at it for any more information. The rest of the problem says the perimeter is 45 inches. That's where our equation has to come from. Now the perimeter of a rectangle means the distance around the outside. So if our rectangle has these dimensions, if we add all of those up, has to come out to 45. We have a linear equation. We need to do some simplifying. Add the x's together, add the numbers together. And we get 6x minus 6 equals 45. Add 6 to both sides, divide by 6, and there's the solution to the equation, not the answer to the problem necessarily. The answer to the problem needs to be the length and the width of a rectangle. X equals 8.5 doesn't say anything until we pair that with what we said in step 1. And so 8.5 is indeed the width of the rectangle, but the length of the rectangle would be 2 times 8.5 minus 3. Now in this one, step 1, we want to read through the problem, get down to the end, and look at the question. How much did she invest in each account? There are 2 accounts, one at 10% and one at 7%. One of them is X. We got to come up with something to call the other one. Look at the first sentence. If she has $12,000 and she invests X in one of the accounts, then 12,000 minus X is how much she has left for the other account. The equation needs to come from the rest of the problem. In fact, taking a look at the interest, we know that the interest earned at 10% plus the interest earned at 7% has to come out to be 960. So what's the interest earned at 10%? Well, it's 10% times however much you invest at 10%, which step 1 we called X. The interest earned at 7% is 7% times however much you invest at 7%. Add those together, you get 960. Now we're through with the thinking part of it. Now it's just doing the steps that are appropriate for solving the equation. 0.07 times 12,000 and 0.07 times X. Put the 2 x's together, 0.10 minus 0.07, subtract 840, divide by 0.03. Step 4, go back and look at what you put in step 1 and make sure everything works out. X equals 4,000 is the amount at 10%, and 12,000 minus 4,000 would be the amount at 7%. Now, the airplane one. Distance, rate, and time problem, these are usually called. But again, we'll start out the same way. Step 1, how long, means we're looking for a length of time. We'll call that x. Now in step 2, rather than just launch in here and try writing an equation for this problem, there is a trick to it. The trick is to construct a chart. In the chart, you want to put over here on the side the two situations. In this one, we've got a southbound and a westbound airplane. And we've got 3 columns, distance, rate, and time. We're going to fill in the chart, then write the equation. Now, the chart you fill in like this. In every instance, there will be something that is given explicitly in the problem. For example, the time that we just came up with is x, so we'll put that in the t column for both of them, since they both travel the same length of time. And it says right here that the one heading south travels 480 miles an hour, so that's the r. And the other one, the westbound one, travels 360 miles an hour, so that's the r for the westbound. Now here's the key to using the chart. In the D column is nothing more than r times t. D equals r times t. And so 480x and 360x are the D columns. Now that we've got that filled in, let's come back and look at the problem. It talks about the distance between the two planes being 2,400 miles. This one's traveling west, this one's traveling south. They're going to stop and have a look at them. Here's the distance between them. Notice it forms a right triangle. The Pythagorean theorem tells us if you label a triangle like this, then a squared plus b squared is c squared. Now, what are the a, the b, and the c? Well, the c is what we're looking for. The a is the distance that the westbound train has traveled. The westbound plane has traveled. That's 360x from our chart. So we'll put a 360x there. The b is the distance the southbound plane has traveled. We'll put a 480x there, and then put those into the equation, and notice we can solve for c. Square those and add them together. You do that on a calculator, obviously. Do the square root of that, and we get c equals 600x. And so the distance between the planes is described as 600x. And it says right there the distance is 2,400 miles. So our equation is 600x equals 2,400. And when we solve that equation, we just divide by 600. And there's only one thing we're looking for in this problem, and x is it. And so our answer is the 4 hours. In the last one, we have a situation where we're talking about times, but we can't equate and combine times. We can equate and combine the amount of something that is done. So the key to this problem, after we identify our variable, is to think of it like this. Not how much time it takes, but the amount of work that's done. And so the amount that the inlet pipe does in 1 hour and the amount the outlet pipe does in 1 hour, when you subtract them, you get the amount that's in the tank. So you can't equate times, you can't combine times, but you can combine the amounts. So what is the amount in inlet pipe 1? Well, if it can complete the job in 8 hours, and we're looking at 1 hour, then it's done 1/8 of the job. The other one took twice as long, and twice 8 is 16, so it's done 1/16 of a job. And we don't know